In the last lecture, I introduced the idea of variables. This lecture kind of extends that discussion, uh, provides some guidelines for naming or identifying variables, classes, and other Java constructs we might have to provide names for. Uh, we also, in this lesson, will discuss literals and expressions, uh, and we'll talk about values that must remain constant throughout the program. Last time we learned about writing a Java program to perform some simple calculations, but importantly we learned how to use the scanner class, uh, that we had to create an object of type scanner. Uh, we had to import the class that contains the scanner class, the package, and we learned that it had several different methods for reading keyboard input of different types. This lesson is we'll talk about identifiers, and particularly those identifiers used to name variables and constants and classes, and provide some guidelines on naming conventions. Uh, Talk again about variables. All right. Uh, Look at some assignment statements. An assignment statement is used to provide a value to a variable. And then we'll look at a new topic, constants. Right? Constants are like variables, but their value remains the same throughout the program. So, we need to start with some understanding of some definitions. The first thing and an important part of this lesson are identifiers. Identifiers, as it says, gives name to things. So, what type of things do we need to name? Well, up to this point, we've been naming our class, and so we have to have names for classes, and we have to name our variables that we'll be using. And we will learn further on that we need to be able to name things like methods, and as you progress with Java, packages and interfaces. So there are several different Java constructs that require naming. A variable is just something that is changeable. It can change within the program. It can change its value. And on the other hand, a constant is something that is unchangeable. Okay? And when we talk about initializing a variable, uh, we're, we're really asking about or talking about establishing a beginning value for that variable. Some more definitions. An expression. Uh, an expression consists. We can combine different variables and constants and literals in our Java program through the use of operators. Right. And the thing to remember about an expression is that an expression evaluates or produces a single value of some sort. Some examples here. Here's an arithmetic expression. And I'm going to take 7 times 9 divided by 23, and I'm going to add student age to it. That's an arithmetic expression. It will evaluate to some single value. Okay? Kind of nonsensical, but it's still an arithmetic expression. We can have a text or a string expression. All right, and that can involve both numeric data and non-numeric data. We've seen string type expressions in our last program where we had to write a message to the output screen expressing what the area of our circle was. And in this expression, we're combining a string, the area of a circle with radius, right, with a value, radius, right, again with another string, is, and another value, area. So we've combined both text and numeric values here to produce a single result. The area of the circle with radius 2 is 14.7, or whatever that might be. Okay. Notice that we have quotes around that string. Okay, and that's important to talk about literals. All right, and that's a literal. A literal is some value that's fixed as part of our source code. Okay, so they're usually they don't require any computation and so forth. So if we look at some values that were fixed in our source code, say in a previous program, we use the 3.1419 for the value of pi when we computed the area of the circle. And so that was a numeric literal. The area of a circle in quotations there is a text literal. Text literals are always enclosed with double quotes. Okay? There's also literals like true, false, null. Well, true, false, you understand if we have a data type Boolean, which means it can only hold a value of true or false, then true or false are literals that we can use with Boolean values. Okay, let's get down to the rules for constructing identifiers for those names that we need to create for things like variables and classes. Right? The first rule is pretty simple: letters and digits, underscore and or $sign. You might want to also think about not using underscore and $sign. They can be somewhat confusing, but they're available. Okay. The identifier, a name, must start with a letter. It could be uppercase or lowercase, and or a $sign and underscore. All right. I would suggest not using those because they can have some special meaning later on in more advanced Java. So at this point, I think let's keep our identifiers to just containing letters and digits, right? Maybe underscores, but avoid the $sign, and especially avoid starting with a $sign or underscore. All right? We cannot start with a digit. Okay? We cannot start with a reserved word. Last week we gave you reserved words. Remember that you can find a list of reserved words in Appendix A on page 1311, I believe. One thing that I insist on, and most of your programming teachers will insist on, is that an identifier must be meaningful. Name things for what they are. Okay. Now, you know that identifiers can be of any length, and so if you're trying to name something meaningful and the name gets exceedingly long, programmers are generally pretty lazy and don't like to type long names. So use of common abbreviations, but at least to the point where somebody understands the thing that what it is, the thing that you are naming. In Java, identifiers are case sensitive. So even though you and I understand uppercase GPA to probably mean the same thing as lowercase GPA, to Java, those two identifiers represent different things. So it's one mistake that we can, or trap we can fall into in programming with Java is, not paying attention to the case of our. Okay, conventions are simply common practice techniques that are recognized professionally. Okay, we've already learned that it's common practice to name our classes starting with an uppercase letter. Okay, all other names, all other things that we will be naming, we will begin with lowercase letters. Okay, sometimes camel casing is used for an identifier that is made up of more than one word. We have examples here of student first name, home address, compute average, right? So you should recognize that the first two probably are naming some type of variable, and the last, since it starts with a capital, is naming a class, right? So you have that lowercase, uppercase, lowercase, uppercase, or vice versa, okay? By convention, constants are named using all capital letters. We'll discuss constants here in a few slides, but in order to recognize the constants and distinguish them between a variable, we use all capital letters. Also, it's also kind of good practice, or can be helpful, to use a naming convention that identifies the type of data that an identifier represents. So in my programming, I like to use the abbreviation for the different data types as the first part of an identifier name. So looking at these examples here, I know that first name is a string, that GPA is a double, and that age is an integer data type. Right? We'll get more into data typing in the next lesson. But consider that useful hint of creating identifiers using some type of indication of the data type that identifier represents. All right, this slide is really pretty busy. It's just kind of a little program snippet to give examples of various things. The first off, it's providing an example of a variable, in the sense that our variables are indicated in the red up there, radius and area, right? And so as far radius begins to be initialized with a value of 1, and then since it's a variable, later on in our program snippet here, we give it a new value of 2. The same as with area. A circle with radius 1 is going to have a value for area that is different from a circle with radius 2 in the second snippet there, part of the snippet. So indicating or just kind of demonstrating that variables can take on different values. Some other things in here to point out. The purple, the 1, the 3.1419, the 2, those are numeric literals. They're values that are part of my source code. Right? In a few slides here, we'll discuss how to maybe avoid some of these numeric literals and use constants to represent them. Okay. And then the blue, it's a text string that is a literal. So that's a text literal. Right. Brown down in the second compute area is an example of initializing a value. So we initialized it at the beginning, and then we initialized it with another, or gave it another value. Most of the time, initializing begins right at we have it right at the beginning of the program, so it's an initial value for that data item or that variable. Okay. The dark green you should recognize as an arithmetic expression, because we're dealing with all numeric things, and the operators, the multiplication signs, are creating taking that expression and creating a single value. It's evaluating to one value. Okay. The pink, that is a string or a text expression, and we know that from our last lesson that we can join text strings with numerics and so forth by using the plus sign, which is, in case of string operators, is called the concatenation operator. Remember, concatenation means joining things together. So we're joining all these little pieces together. The text literal with the value for area, with another text literal with the value for radius. Last time we discussed in variables, okay, re-emphasizing that when you declare or define a variable, you have to tell it its data type, so that in this slide we're creating three different variables: an integer named age, a double named radius, and a character variable named first initial. Normally, I like to see all the variables that a program is going to be used declared right after the definition of the main method, right at the top of the main method. So now we know, all right? It's kind of like that recipe we saw last time. We have all of the ingredients listed in one place. Imagine how confusing that recipe would be if the ingredients were mixed in with the instructions, right? So I think it's much cleaner programming if we name put our variables names at the beginning of the main method. As we learned last time, the equal sign is the assignment operator, and it simply means that the value on the right hand side of the equal sign will be assigned to the variable on the left hand side of the equal sign. We see that we are assigning, in this case, literal values, and it's important that you understand that we can't put a literal on the left side of the equal sign. It wouldn't make sense to say 10 equals age. It doesn't. That's nonsense. And first of all, I don't think the compiler will let you get away with it. And if it did, you most certainly would have some type of runtime error that would crash your program, I believe. All right. So we have some different literals there. We have an integer literal. Notice a decimal literal. A decimal literal has to contain the decimal point. And since radius was defined as a double in our previous slide, right, in order to be sure that we initialize the value or give it a value that is a double, we use the decimal point, right? And then first initial, all right, assigning it a character or a text value. So pretty straightforward. in terms of how we use the assignment operator, the equal sign. Might just put a little note in your memory that later we'll learn about using two equal signs. So an equal sign, a single equal sign, is an assignment operator, right? It is not a test for equality. I can't say be testing age to be equal to 10 with the single equal sign, right? We'll learn when we go through the selection statements that we need to use a double equal sign to test for equality. So there is a difference. A single equal sign is an assignment operator, and a double equal sign is used to test for equality. Need to point out here that assigning a character literal or a text literal in Java requires double quotes. Your compiler will throw many errors at you if you use single quotes around your text for string literals. Last lesson I talked a little bit about this practice of declaring and initializing variables in one step as is shown here. I think it can create a great deal of confusion in your programs if you don't declare your variables at the top of your main method, like I suggest, because if we're declaring variables on the fly down in the middle of code, and sometimes you can have hundreds of lines of code, it would be very difficult to understand, well, where was that variable declared? Initializing it, on the other hand, at a point where it's needed is not a problem. But in this case, declaring it and initializing it someplace else in code might not be a good practice. If we want to initialize a variable at the time we declare it at the beginning of our program, that's not an issue. But it's the practice of declaring and initializing variables someplace in the middle of code that I think becomes a very risky business. Okay, constants. Okay, constants are data items, all right, whose value cannot be changed. Their value is set at the time that you declare them, and so you should find, based on my recommendations, you should find constants defined right after your declaration of your main method, right at the top of your code, so to speak. Okay, and the way we declare something to be a constant is that it's declared with the reserved word final. This is the final value. Notice then that we give it a data type, right, like any other piece of data, all right, and in these cases we've used all uppercase to name our constant. Okay, so that when we see an all uppercase name in our programming code, we know that it's a constant. Now, what is the advantage of using constants? So what is the advantage of using pi in our compute area equal radius times pi? Well, suppose that calculation is used many times in the program, okay, different places within hundreds of lines of code, and we want to change the value we use for pi to be less precise. So instead of using 3.14, 159, every place that we calculate the area of the circle or we use pi, we want the value to be 3.14. Right? So as if we used it as a numeric literal, as we had in our program example last time, within this 100 lines of code, we would have to find every place that we use 3.14159 and change it to 3.14. If we had used a constant named pi, then the only place I have to change is in the declaration of pi and the value that I set for it. So I have to change it one place. Final double pi equals 3.14. So constants become are very important alternative to using literals. Right? Sometimes you might be faced with calculations, and if you used a literal, it might not be clear what that literal represents. Whereas if you use a constant and you use the naming convention of making a meaningful name for the constant, then using that in a calculation would be make the calculation make more sense. So favor using constants over using literals. Yeah, a short lesson, but a lot of important stuff in there. If you practice good programming conventions, your programs are going to be easier to read and understand. And yep, you need to remember all this stuff. Okay, see you next time.